Section 4.3, Example 2 on page 257, we have the following are equivalent statements about a real number b and a polynomial. P of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus and so on all the way to a sub 1 times x plus a sub 0. X minus b is a linear factor of the polynomial p of x. B is a zero of the polynomial function y equals p of x. B is a root or solution of the polynomial equation p of x equals 0, and B is an x-intercept of the graph of y equals p of x. So for example 2, it says, what are the zeros of y equals x plus 2 times x minus 1 times x minus 3, graph the function. So the first thing we're going to do is figure out what the zeros are, which is what we did in chapter 3. Anytime you have different linear expressions being multiplied together, we can set this whole thing equal to 0 and solve for each piece individually using the zero product property. So remember, in order for this whole expression to be 0, one of these pieces must actually be 0. So x plus 2 equals 0, or x minus 1 equals 0, or x minus 3 equals 0. So we will solve for each one of these. For the first one, we will subtract 2 from both sides to get x equals negative 2, or for the second one, we can add 1 to both sides to get x equals 1, or for the last one, we can add 3 to both sides to get x equals 3. So this gives us our 3 zeros of the function. That means that at negative 2, 1, and 3 on the x-axis, we should be crossing the x-axis. So we should be graphing those points as zeros of the graph. Now, to graph this function, we can just plug in some values in between these points. So if I want to know what the y value will be in between negative 2 and 1, I can plug in negative 1 and 0, and then in between 1 and 3, I can plug in 2. Using the table below, you can see that if we plug in negative 1 and simplify, you'll get 8. So we have the point negative 1, 8. If you plug in 0 and simplify, you get 6. So you get the point 0, 6. And if you plug in 2 and simplify, you get negative 4. So you get the point 2, negative 4. So that is step 2. Find the points between the zeros. Step 3 is to determine the end behavior of the graph. Notice that we have x and x and x. If we multiply all 3 of these out, we're going to get an x cubed. So that would be cubic. Each of these x's is positive, so it would be a positive x cubed. So therefore, there is a coefficient of positive 1. And if you remember the chart from the previous lesson, if we have a cubic function with a positive coefficient, the end behavior is down and up. Once I know all the points that I need to plot on my graph, I know I need to go to negative 2 and then all the way to 3 on the x-axis, so I can count by ones because here's negative 2, here's 3, that fits if I count by ones. However, my y values, I know I'm going to want to get up to 8 and down to negative 4, so I went ahead and counted by 2's. So 2, 4, 6, 8, negative 2, negative 4, that way I can get all the values I need. Now, you don't have to count by the same on each axis, but you do have to count the same on both sides of the axis. So on the positive side, I counted by 1, so on the negative side, I'm going to count by 1. Same thing on my y. Since I'm counting by 2, I have to count by 2's all the way. Let's go ahead and start by plotting our zeros. So if I know I have a 0 at x equals negative 2, I'm going to go on the x-axis and plot a dot on negative 2. Same thing at x equals 1, and then again at x equals 3. Then I added some extra points. So we have negative 1 all the way up to 8. And then 0 will be at 6. 2 is going to be negative 4. And now using our end behavior of down, up, I know starting on the left, I'm coming from the bottom. So it would be pointing down. And then I follow my points and end going upwards. Now this is just a sketch. This isn't perfect. So I'm not 100% sure that that's going to be my highest point. It might be a little bit over. Same thing with the bottom. We are just sketching a graph, so it's not going to be perfect when you draw it by hand. Here's all the work that we just did, and here is their sketch. And again, notice that it says sketch the graph. So again, the maximum's actually just a little bit past where we were, and the minimum's pretty spot on, but it appears to be just a tiny bit over. Of course, if we wanted exact values of anything, we could use Desmos.com to graph this, or the Desmos app. Now I want you guys to try to find the zeros of this function and graph the function. This ends up just being a quadratic, so you absolutely can graph this by hand.